Alright guys, so welcome to the second part of your hydrocarbons. So today we are going to learn about alkenes. So hopefully you already studied about alkenes. So if you haven't go through the alkene, make sure you go through the alkene notes first or the alkene video first before you proceed to this video. Alright, so alkenes. Alright, so first things first, general formula. Okay, we must always know the general formula. Okay, so for alkene, the general formula is CnH2n. Whereas for alkane, if you notice, right, the general formula for alkene, okay, alkene is CnH2n plus 2. So if you notice the difference between the general formula between alkene and alkene is that alkene, you have an additional 2 hydrogens. Alright, so for alkene, we start with 2 carbons. Okay, there is no 1 carbon for alkene. Alright, alkene you start with 1 carbon, but alkene you start with 2 carbon. There's a reason for this. Okay, and then remember for alkene, how do we know whether it's alkene or alkane is because of this one. Alright, all alkenes will have the double covalent bond, or in short we call it as double bond. Okay, so an alkene is also classified as unsaturated hydrocarbons. Okay, whereas for alkane, we call them saturated. Okay, so you need to be able to differentiate which one is saturated, which one is unsaturated. Right? Technically, alkene is unsaturated. Okay, meaning you have the carbon double bond. Okay, so for all unsaturated hydrocarbons, you must at least have one double bond. Alright, okay, one double covalent bond between the carbon atoms. Now remember, when we say double bond, meaning we are sharing in total 4 electrons. Okay, so for all alkenes, the carbon is sharing 4 electrons between the atoms. Now, let's say if I have a C carbon double bonded to an O, this is not called alkene. Okay, this is not alkene. Alright, remember that alkene, this particular name is only given when the double bond is in between 2 carbon atoms. Okay, so don't confuse. Alright. Okay, so the structural formula, remember for carbon, the total number of bonds around a carbon atom is only 4. So if I calculate the number of carbon atoms for this one, 1, 2, 3, 4. For this carbon atom is also the same, 1, 2, 3, 4. So make sure you always calculate the number of bonds around your carbon when you draw the structural formula. Alright, make sure you only have 4 lines around the carbon. Okay, now the first member of alkenes has 2 carbons. Okay, reason why? Because your double covalent bond can only be formed between 2 carbon atoms. Alright, so remember, for alkene, you always start off with C2. Okay, so the naming, alright, the prefix is the same as the one that we learned in alkane, meaning that methane, ethane, propane, right? But in terms of alkene, since now this is about alkene, meaning that the N will end as ENE, meaning it will become ethene, propene, butene, pentene, so on and so forth. Alright, so let's just look at the table here. Okay, so remember your molecular formula will depend on the general formula. Okay, for alkene is CnH2n. So you start with 2 carbons. So C2, this one will become C2H4. And then when you draw the structural formula, remember you always draw out the carbon chain first. Alright, since this one is double bond, meaning I put the double bond here. Okay, and then I'm going to fill up with the hydrogens. Okay, hydrogens, 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 hydrogens. And then make sure you calculate to see that the number of bonds for around carbon is only 4. And then make sure your structural formula is the same as your molecular formula. 2 carbons, 4 hydrogens. So calculate 1, 2, 2 carbons, 1, 2, 3, 4, 4 hydrogens. Alright, so your name here, 2, is alkene. Okay, make sure you spell it correctly. Alright, so 3 carbons. So this one will become C3H6. Okay, you always draw the carbon chains first. Alright, now in this case, the double bond, I can put it in either one. I can put the double bond here, no problem. Or I can also put the double bond here. Okay, it's the same thing. Alright, so once you put the double bond, always put the double bond first before you fill in the hydrogen. Alright, if not, you're going to fill in the wrong thing. So make sure you only have 4. Okay, 1, 2, 3, 4. Alright, and then you fill in your hydrogen. Okay, so normally your mistake will be where is that your mistake will be around this part here. Okay, you forgot here you have 2 bonds and then you go and draw another one here. So this one will make it 5, which is wrong. Alright, so this one the name will be propene because it's 3 carbon. Okay, so the next part, I believe you can try and do this on your own. So C4, this one will become C4H8. Alright, so in this case, when you draw the carbon chain, first you draw 4 carbons and then only you put the double bond. So your double bond can go either here or here or here. Okay, it doesn't matter where. Alright, so I can put it like, for example, I can put it here. Okay, so once I put the double bond here, then I'm going to fill up the carbon bonds here. Alright, I'm just going to put all the carbon bonds here and then I'm going to fill in the hydrogens. Okay, hydrogens. Okay, right, so make sure you calculate and that you have the same molecular formula here. So 4 carbons and then 8 hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8. So this is correct, right? So this one, 4 carbons is called but. So this one we'll call it as butene. Okay, so you can try and complete all the what they call table below. So 5 carbons until 10 carbons. Alright, so this one will be pentene until that's it. Okay, draw out the what they call structural formula and you can put the double bond anywhere in the structure. Just make sure that the total bonds around the carbon is 4. Alright, okay, so the next part will be on the physical properties. Alright, so if you look at the physical properties of alkenes, okay, technically they are almost the same as alkane, right? Meaning they are molecules, okay, and then they are bonded by strong covalent bond. Okay, remember atoms are bonded, atoms in a molecule are bonded by strong covalent bonds. Okay, and then remember that molecules are being held together by weak van der Waals forces. Okay, so alkenes are also insoluble in water, same as alkene, alright, but they are soluble in organic solvents. Okay, cannot conduct electricity. Okay, why cannot conduct electricity? Because this one is molecule, so no ions. Okay, so remember to be able to conduct electricity you must have ions, but in this case since it's a molecule meaning you don't have ions. Right, low melting and boiling point and less dense than water, meaning if I mix the two solutions, alkene will be on top, water will be at the bottom. Alright, so the molecular formula here again, okay, general formula is CnH2n. Alright, so that's it. Complete the table here and I believe you can calculate the molar mass. So C2H4. Okay, you have the melting point and the boiling point. Now physical state at room temperature. So this one, remember this one, the temperature is 24 degrees Celsius. So we need to look at the melting point and boiling point to know whether to know the state of the particular molecules at 24 degrees Celsius. So we just compare. So if I look for ethene, 24 degrees Celsius is already above the boiling point. So meaning that ethene has already become gas. Now, if we look at propene and butene, it's also the same case because 24 degrees Celsius is already above the boiling point. So meaning they have already become Alright, now, but for pentene, if you look at the melting and boiling point, right? So 24 degrees Celsius is above the melting point, but it's before the boiling point, meaning 24 degrees Celsius is here. Okay, so if you remember, if you are in between, meaning above melting point already melted, so it's already liquid. Alright, okay, so remember how to determine the state of any substances. So we refer to the melting point and the boiling point. If the temperature is below melting point, it becomes solid. If the temperature is between the melting and boiling point, it's liquid. If above the boiling point, then it's gas. Okay, so try and complete the table here. I believe by now you can calculate the molar mass also, alright? Okay, so the physical state at room temperature. So based on the table here, if you notice the first three elements, or not elements, the first three molecules in alkene, ethene, propene, and butene, they exist as gas. Okay, whereas the others, if later on when you check, all these are actually liquids. Right, from pentene until decene, okay, all are liquids. Okay, so generally alkenes have low melting and boiling point, and the reason why they have low melting and boiling point is because of the weak van der Waals forces. So if you are weak van der Waals forces, meaning you need less heat energy to overcome it. All right. So generally, if you look at the table here, you will notice that actually their melting point and boiling points are actually lower compared to other substances. But if you notice from from ethene until decene, meaning as the number of carbon atom increases, the melting point and boiling point also increases. If you look from here to here, okay, you will notice that the melting and boiling points are slowly increasing. Now, this is because when the number of carbon atoms increases, right, the size of the alkene also increases. Okay, so when size increases, remember that I showed you the example when I explained for alkene. When size increases, meaning that the distance between the two molecules is shorter, therefore the van der Waals forces is stronger between the molecules. Okay, so you are going to need more heat energy to overcome the force. Therefore, the melting and boiling point will increase, right? So remember, this one for example is C2. Okay, this is ethene. Okay, this is one ethene molecule. Ethene molecule. All right. So here, the distance is shorter between molecules. But let's say we have what they call butene, 4 carbons. All right. Since the size is now bigger, right? So doesn't matter lah. Okay, like that. Okay, so when the size is bigger, the distance here is shorter, right? Meaning the distance between the two molecules are shorter. Therefore, the van der Waals forces is higher. Okay, so remember, shorter distance between molecules, van der Waals forces higher, meaning you need more heat energy to overcome the forces. Hence, the melting and boiling point will increase. Okay, so that is the physical properties for your alkene. Alright, so next we are going to go into the chemical properties. Okay, so technically we say that alkenes are more reactive than alkenes. Okay, and the reason why is because they have the double bond. Alright, so all chemical reactions of alkene will happen at the double bond. Okay, so it doesn't matter how big the structure is, you always see where is the double bond because all the chemical reactions will happen there. Alright, so technically for alkenes you have two chemical reactions. The first one is the same as your alkenes, which is combustion. Alright, and the second one is addition. Okay, so for alkene, you only have one substitution reaction. But for alkenes, you will have 6 different addition reactions. So it's actually a lot. Alright. But first, we're going to go into combustion first. Now remember that combustion meaning that you take the hydrocarbon and then you burn in oxygen. So the product is the same. You still get carbon dioxide and water. Alright. And then remember, when you balance the reaction, you always balance carbon first, hydrogen next, last only you balance the oxygen. And for combustion reaction, we can use fraction when we balance the oxygen. So let's try out this one. So this one is ethene, 2 carbon. So we try and balance the carbon first. So I put 2 here. Right. Next, we look at the hydrogen. So here I have 4 hydrogens. So here I put 2. So this one will become 4. And then I calculate the oxygen. So 2 multiply 2, 4 oxygen plus 2, so 6. So here I will put 3. Okay, so let's look at the next one. 3 carbons here. So here I put 3. And then 6 hydrogen here. So here I'm going to put 3. Right, let's calculate for the oxygen. 3 multiplied to 2, this is 6. Plus 3, total is 9. So 9 is an odd number. Okay, so meaning here I can put fraction 9 over 2. Alright, and the last one for butene. So 4 carbons, 8 hydrogen. So here I'm going to put 4. Right, so let's calculate the oxygen. 8 oxygen plus 4 oxygen is 12. So here I can put 6. Okay, so that is how we balance the combustion reaction for alkenes. Alright, so for alkene, incomplete combustion will produce carbon monoxide and carbon. Okay, so meaning if you don't have enough oxygen, or what they call, you burn with limited supply of oxygen, not enough oxygen, what happens is that instead of getting carbon dioxide, you are going to get carbon monoxide. Okay, or you're only going to get the carbon only. All right. So a very important thing here is that when we compare the combustion between alkene and alkene, okay, there is a difference in the observation. Meaning if I burn alkene, I will see more sooty flame. Now, sooty flame here meaning that they are going to produce more black smoke. Okay, so if you burn the alkene or alkene, you're going to see black smokes coming out. Okay, so that is what we call sooty. Alright, so technically alkene will have more black smoke, and the reason why they have more black smoke is because the percentage of carbon in alkene is actually higher than alkene. So what do we mean by that? So we are going to show you the calculation. Alright, so this is the comparison between alkene and alkene. Okay, remember this one is alkene. Alright, this one is alkene. So propane, propene, both have 3 carbons. Okay, both have 3 carbons, but the percentage of mass of the carbon in these two compounds are different. So we calculate the percentage of carbon by mass. So how we calculate is that we calculate the total mass of carbons divided by the total molar mass of the molecule. So here I have 3 carbons. Okay, and each carbon the mass is 12 divided by the total molar mass here. Okay, so 3 carbons multiplied to 12 plus 8. Right, because each hydrogen is 1, and then we are going to multiply to 100%. Alright, so this one if you calculate, right, I think you should get around 81% if I'm not mistaken. Alright, so here you should get around 81%. Okay, roughly 81%. Okay, but for in this case, the percentage of carbon over the total will be slightly different. Okay, the reason being is because you have lesser hydrogens. So still the same thing, you take the mass of the carbon divided by molar mass of the compound. Okay, so 3 multiplied 12, okay, plus, but here you only have 6 hydrogen. Alright, and then multiply to 100%. So this one, when you calculate, right, I think you will get around 85 to 86% if you're not mistaken. Okay, so based on these two calculations, right, you can see that the percentage of carbon by mass in propene is actually higher than propane. Therefore, when you burn propene, you are going to see more sooty flame. Okay, so I'm going to show you a video about this. So this one, they are burning cyclohexene and also cyclohexane. Okay, one is alkene, one is alkane. Alright, so this one, they are doing it slow-mo so that you can see the sooty flames coming out. Alright, so you can see here, there are black smoke slowly coming out from the alkene. Okay, whereas for the alkane, as you would see, right, the amount of soot coming out from the alkane is actually lesser compared to alkene. You can see here a lot of sooty flames coming out. Okay, and the reason why you have more sooty flames here is because the percentage of carbon by mass is higher in alkene compared to alkane. Okay, so technically, that is how we can differentiate between an alkene and alkene. Meaning, if I want to know which particular compound is alkene or alkane, I take the two substances and then I burn. And then the one that gives out more soot, that one will be the alkene. Alright? Okay, so I hope you understand how to differentiate between an alkane and alkene through combustion. Okay, you calculate the percentage of mass. Alright? Alright, so that is only it for combustion. So for the next part, which is the addition reaction, alright, so for this part, because there's a lot, so I'm going to separate it into another video. Okay, so check out my next video, okay, about the addition reaction for alkenes. Alright,